Welcome to this lesson on conditional processing in C. To perform meaningful work, our programs need to be able to make decisions. All the programs that we've looked at to this point are sequential in nature, meaning they start at the first statement in the program, execute it, move to the second, execute it, move to the third, all the way through the last program in the statement. When we start making decisions, there's going to be a set of program statements that we execute when a condition is true. There may be a set of program statements that we execute when a condition is false. We're going to use if-else processing. And so in this lesson, we'll take a look at the C if statement, the C if-else statement, as well as the C switch statement, which allows us to quickly test a set of cases to see what execution we should perform. So let's go ahead and get started and start making decisions in our programs. When our programs make decisions, C programmers will say our programs are performing conditional processing. The two most common statements that we use to perform conditional processing are the if statement or the if-else statement. Let's look at a simple example. We're going to drill deeper in the next couple programs, but let's go ahead and get started. In this case, we have a program that declares a variable called age and initializes it to 22. We might have a program that prompts the user to enter their age. The program then uses an if statement to see if the age is greater than or equal to 21. You can see that the C greater than or equal than operator is the greater than symbol with the equal sign right next to it. If the value in age is greater than or equal to 21, the program prints the statement, "We're going to Vegas." Otherwise, it prints the statement, "We're going to Disneyland." So the if-else statement allows us to provide two types of statements. One that executes if our condition is true, and one that executes if our condition is false. So let's go ahead and run this. And sure enough, because our age 22 is greater than or equal to the value 21, our if statement evaluates as true, and we print the message, "We're going to Vegas." So for many programs, it's going to be important to understand how C represents the value true and how C represents the value false. And so in general, any value that's not 0 is considered a true statement. So the number 1 would be considered true. The number -1 would be considered true. The value 0 is going to be considered false. So let's look at how we might use these values. The first if statement just tests the value 1. And if it's true, it prints the statement, "1 is always true." The second does a comparison, and in C, the double equal sign is our equality operator. And so it's saying if 1 minus 0 is equal to 1, print the statement. The second statement just tests, or the third statement just tests 1 minus 0, an expression. And so it will calculate the result of the expression, and then it will look at it and see, is it 0, is it a non-zero? And then the last statement tests 0. And 0 is false in C, so that statement shouldn't execute. Let's go ahead and run this. And so it tells us 1 is always true. Then our expression, 1 minus 0 equals 1. And so what you should note is the double equal sign. In C, the single equal sign is the assignment operator. That's how we assign a value to a variable. The double equal sign is how we test a variable's value to be equal to another value. So when you start performing conditional operator, as well as iterative operations, it's important that you understand the terms simple statement and compound statement. A simple statement is a single statement. So you can see that we have the value age equals 21. That's a simple statement. A compound statement appears within braces. And so you can see that we're declaring a variable called age, initializing it to 21, and then we're doing a print statement. And so let's look at our program. It's not doing any conditional processing. There's no if statement in it. It just shows us that we can create a simple statement anywhere in our code. In this case, our statement is int a equals 0, and then declaring b. And then we put a compound statement. You normally wouldn't do this in a sequential program where we're just executing one statement after another, but you'll see that we do it a lot with if statements while statements, for statements, as we start to perform conditional and iterative processing. If we run this program, you can see that C executed both our simple and compound statements. So when we use if statements, a lot of times we'll have just a simple statement, a single statement following the if. And when we do that, we don't need to put that statement in braces. We can also, if we have multiple statements that we want to execute when the if statement is true, then we use a compound statement, putting those within braces. And so if we look at our first program, it declares a variable called pet and assigns it value 1. And remember that 1 is going to be considered a true value, and 0 it will be considered a false value. And so in this case, our value 1 for the program means that they have a dog, and 0 would mean that they have a cat. And so we're testing if pet, meaning if 1, that's going to be true. So we should see our print statement print out. And so we've had a single statement, so we had a simple statement following our if. In our second program, if we take a look at it, we have a compound statement. We're assigning pet, again, to value 1, and if they have a pet, we're going to execute these two statements. Dogs are great, and I have 3 dogs. So let's go ahead and run this program. And sure enough, our condition was true, so it executed both of the statements that follow. If you change that value pet equals 1 to pet equals 0, our if statement will evaluate as false, and neither one of those two statements will execute. Now we talked about the fact that the double equal sign in C is a test for equality. The single equal sign is the assignment operator, which assigns a value to a variable. Let's look at our first program. It uses both. First, it declares two variables, A and B, of type unsigned int. It uses the assignment operator, the single equal sign, to assign them both the value true. It then uses an if statement to test is A equal to B. And so it's a double equal sign. We're testing for equality. So the single equal sign, assignment, double equal sign, test for equality. Let's go ahead and run this. And it tells us that A and B are equal, and they should be. We assign them both the value true. Now let's take a look at a program that has a bug in it. And it has a bug that can be difficult to detect when you're trying to figure out where's my logic there. And so C will allow us to do some things that can get us in trouble if we're not careful. And so in this case, we're declaring a variable called A, and we're initializing it to the value 0. We're using the assignment operator. But within an if statement, or a while statement if we're looking at iterative processing, C allows us to test the value of an assignment. And so what we really wanted to do here was test is A equal to 2. And instead, what we assigned was the value 2. We used the assignment operator, not to test for equality. And so this is a bug in our code, but let's run our code. And so in this case, it did say A is equal to 2. Why? Because the value 2 is not 0, which C would consider false. And so let's change this for a second. And so what we really want to do is test for equality. We want the double equal sign. And so when we run this program, it doesn't display our message because A is not equal to 2, but rather A was equal to 0. That's what we initialize A to at the top of our program. So again, the single equal sign is the assignment operator. The double equal sign is the test for equality. When we perform conditional processing, a lot of times we'll test how one value relates to another. Is it greater than? Is it less than? Is it greater than or equal to? Is it equal to? And so some of our additional relational tests are the greater than operator, the less than operator, the greater than or equal, or the less than or equal. And we'll also see that we've got our test for equality, the double equal sign, as well as the not equal symbol, which is an exclamation mark followed by the equal sign. Let's use our relational tests in our program. We're declaring two variables, A and B, initializing A to the value 2, B to the value 3. We then test, is A greater than or equal to B? If it is, we'll say it's bigger. Then we test is A less than B. If it is, we'll display a message that says it's smaller. Let's go ahead and run this. And sure enough, it says a 2 is less than B, which has the value 3. When we perform conditional processing, there's going to be a lot of times where we want to test multiple conditions. Is today Sunday, and is the hour greater than 10? It's probably time for a football game. And to do so, we use the C and operator, which is the double equal sign. And so in our program, we're declaring a variable called day, and we're assigning it to value 5. Now you can see that we have a comment that says, well, Sunday's 0, Monday's 1, Tuesday's 2, and so on. So Friday would be the value 5. It's then looking at a variable called hour and initializing it to 6. Our if statement tests, is today equal 5, is today Friday, and is hour equal 6? If it is, we're going to print the message, it's happy hour. And so let's go ahead and run this. And sure enough, we get the message that says it's happy hour. And so the double ampersand is the C logical AND. And you've seen that the single ampersand is the C bitwise AND. You need to make sure that you use the correct one. C would allow us to use the single equal sign in this test, or the single ampersand in this test. But we want to do a logical comparison. So the logical AND is the double ampersand. Just as there's times where we want to test if one condition is true and a second condition is true, there may be times where we want to test is one condition true or a second condition true. And C provides a logical OR operator that allows us to do just that. In this case, the OR operator is the double pipe symbol. And so we can test, is today Saturday or is today Sunday? Because if it is, it's going to be college football or pro football, so turn on the football game. Let's look at our program, and it's doing a similar test. It's got a variable called day, and it's assigned to value 0. And the comment tells us that that's Sunday. And so our test is testing, is today or is day equal to 0, Sunday, or is day equal to 6, Saturday? If it is, there's going to be football. And so if either of those two conditions are true, our if statement is going to evaluate as true. So with the logical AND, both conditions have to be true. If either one is false, the condition's false. But with the logical OR operator, either one of the two conditions can be true for the condition to evaluate as true. Now, to help us perform conditional processing, C provides the NOT operator. And the NOT operator takes an expression, and if it's 1, converts it to 0. So not 1 is 0. If it's 0, it would convert it to 1. And so in this case, we've got a program, and it's assigning a variable called happy, the value 0. Our comment says that means the person's sad. If the value is 1, that means the person's happy. And so our test says, if not happy, it prints a message, don't worry, be happy. And then it tests, if not 0, remember that 0 is false in C. And so if we run this program, we see both messages. That's because the variable happy contains the value 0, the C false, and so a not false is true. And then remember down at the bottom where we're just testing a not 0, that's the same as saying not false, and that would also evaluate to true. So both our print statements print in this case. So earlier we saw a bug that happened when we meant to test if a variable had a specific value, but rather than using a double equal sign, we use a single equal sign, which is an assignment. And so C allows us to test the result of an assignment. We can use it in if statements, we can use it in our iterative statements, our while, our for, our do loops. And so let's look at this program and it will start to make more sense. We've got a variable called pet. We've got a variable called dog, which has the value 1, and a variable called cat that has the value 0. Our first if statement tests the value that's being assigned to pet. And so we've got it in parentheses to try and make it a little more clear. So it's saying take the value of dog, which is 1, and assign it to pet, and then test, was it equal to 1? And if it is, it says you've got a dog. Our second if statement tests the assignment without our equal sign. It's just saying, is pet, the value that is assigned to pet, is that a true value? This can cause a tricky error because did you mean to actually do the assignment, or were you wanting to test if pet is equal to dog? If pet is equal to dog, you'd use the double equal sign. If you want to test the assignment, you should show it as we've done here. And then the third test is clear. It's just testing if pet is equal to dog. And so let's go ahead and run this program. And so our first if statement, if the value that's assigned to the variable pet is equal to 1, it says you got a dog. That's our tricky one. That's where we're meaning to test the value that was assigned to a variable. The second one's the one that's confusing. Are we wanting to assign a value to pet, or are we wanting to test if it's equal? If we want to test if it's equal, we use the double equal sign. If we want to do test the assignment, we do it here. You're going to see this a lot in C programs. It's a good shorthand notation that allows us to write some concise code, but you need to be aware of when you see the single equal sign, you're testing the result of an assignment. To test equality, you use the double equal sign. And so we said a simple statement is just a single statement. And a compound statement is a group of statements that's contained within left and right braces. We typically use compound statements with our conditional operators, if, else, as well as our iterative operators, for, do, and while. And so in this case, we've got a variable pet. It's being assigned the value 1. That means they got a dog. And then we're testing, is pet equal 1? If it is, we've got a compound statement. It's going to execute both of those statements. If it's not going to execute either of those statements. And so then we have an if statement to test to see whether or not it's 0. If it is equal to 0, it says you've got a cat, and cats are great. And so let's go ahead and run this. And sure enough, we see you got a dog, and dogs are great. If we were to change our assignment value and say pet's equal to 0, and run our program again, it'd say you got a cat, cats are great. So you can see it skipped the first compound statements, you got a dog and dogs are great, because the condition was false. But it did execute the second compound statements, you got a cat and cats are great, because that condition evaluated as true. C allows us to declare and initialize variables following any compound statement. We know that a compound statement is a set of statements contained within left and right braces. And so in this case, we have our variable pet, which we're assigning the value 1, and then we're having a test, is pet equal to 1? And we've got some compound statements. So C allows us to declare a variable, which we do here, number of dogs, and initialize it to 3, following our brace. And so you'll see this a lot where programmers will wait to declare a variable until they need that variable. So they don't need number of dogs if the condition isn't true. But since they do, they're putting it or declaring it within the compound statement. And so in this case, they're creating a variable called number of dogs, assigning it to value 3. And it says, you have a dog. Actually, you have, and then it uses a variable. So let's go ahead and run this. And sure enough, our condition evaluated as true, because pet is equal to 1. We declared our variable, and then we printed that variable's value. So as we look at different iterative and conditional operators, a lot of times you'll find that the programmers will declare a variable following the braces for the compound statement. Now, the number of dogs is only known within those braces. It's the scope of the variable. If we tried to, outside the braces, print the value of number of dogs, the C compiler would say, I don't know that variable. So the variable scope is contained to the compound statement within which it's declared. When we use conditional operators, if statements, else statements, or iterative operators, while, do, or for, We want to use indentation to help improve the readability of our code. We want to make it easy for the programmer who's reading our code to tell which statements correspond to the if statement, which statements correspond to the else statement, which statements correspond to a while statement. And so by indenting our code, we can easily tell. Let's look at this first program. It's not indented at all. And so it's hard to tell. You know that the if statement is a compound statement, so it's got some one or more statements are going to be associated with it. This is the same program we just looked at, where we declare the variable number of dogs and then print how many dogs the person has. But because we don't indent it, it becomes difficult to read. Now the program's going to compile and run successfully. So we ran it and we saw the number of dogs, but it's really difficult to read. Let's look at the second program. It's using indentation to help us tell which statements are related. So it's easy to tell which statements are related to main due to the indentation, and then which statements are related to the if statement. And so as you create your code, indent 1 or 2 or 3 spaces, and just do it consistently so things line up. You can see how our braces line up. You can see how our code within the braces line up. That will improve the readability of your code. So far, all of our tests have dealt with integer numbers, and you've learned that a single precision number, a number of type float, has about 6 or 7 digits of significance. And then after that, the digits are maybe not accurate. And so, because of how programming languages have to represent floating point numbers using binary, you need to be careful when you test with floating point numbers. And you can get some tricky bugs. And so let's take a look at a simple example. We got a tax rate and it's 0.65. Well, using the number of digits in a single precision number, we can't exactly represent the value 0.65. And so let's go ahead and run this program and see what the problem is. And so we have assigned tax rate to value 0.65. We then test, is tax rate equal to 0.65? It should be. We just assigned it. But C can't represent the number 0.65 exactly using the fixed number of binary digits that it has for a type float. And so we print out the value of tax rate, and we can see, sure enough, it's 0.649999. It's almost 0.65, but it's not represented exactly. This is a precision error, and it's inherent in all programs, regardless of programming language. And so how do I solve for the problem? We have a test down below that says, let's see if it's really close to that value. And so we're taking the value 0.65 and subtracting our tax rate. And if it's within 0.001, we're saying, yep, it's close enough. So let's go ahead and run this, and sure enough, it's identified our problem. But as you work with floating point numbers, you just need to understand that any programming language is not going to be able to accurately represent every number. Most numbers it can, but there's going to be a set of numbers that it can't. It can lead to bugs that are really difficult to detect. So far, we've only used the if statement to test whether or not a condition is true, and when it's true, we've executed a series of statements. C also provides the if-else statement. It allows us to provide a set of statements that execute when a condition is true, as well as a set of statements that execute when a condition is false. And so in this case, let's look at a simple if-else statement. We've got our variable pet, we've assigned it the value 1, that means they have a dog, and then we test, is pet equal to 1? If it is, it says you have a dog. If it isn't, it says you have a cat. So let's go ahead and run this. And sure enough, it says you have a dog. But what if we change that assignment to 0? If we run it again, it says you have a cat. So in this case, it tests, is pet equal to 1? It's not, because 0 doesn't equal 1. So it does not execute the you have a dog statement. But instead, it falls through to our else and says, you have a cat. Your programs are going to make extensive use of if-else statements as you move forward. So in the previous program, we learned that C provides the if-else statement that gives us the ability to execute one set of statements when a condition is true, and another if the condition is false. Those statements can be a simple statement, or they can be a compound statement grouped within left and right braces. So let's take a look at this program. We've got our variable, pet, we've assigned it to value 1, and then we test if pet's equal to 1. If it is, we're going to execute those two statements, that compound statement. If it's not, we're going to execute the compound statement that follows. It has two printf statements. Let's go ahead and run this. And sure enough, it says you have a dog and dogs are great. Now, if we were to change our variable assignment from a 1 to a 0, from a dog to a cat, and rerun this, in this case, our if statement condition fails, so it's not going to execute those statements, but instead it's going to fall down to the else statement and say, you have a cat, and cats are great. So when we work with if-else statements, there's going to be times where we want to test a condition. Is today Sunday? Then maybe we want to test a second condition. Is today Sunday? If it's later than noon, do something. And so we call that an if-else statement. We need to be careful with those because they can create bugs that are difficult to declare if we're not paying attention. And let's look at our first program when we've got an example. We test to see if the pet is equal to 5, is equal to 1. And if it is, we have another test to say, is the number of dogs greater than or equal to 5? If it is, it displays the message, you have many dogs. So we're doing one if statement, and if it's true, we're doing a second if statement. Now, if we look at our indentation, it says if pet is equal to 1, do these statements. Otherwise, write the message, you have a cat. Let's run this program. And so we know that the person has a dog. It assigned pet equal to 1. It said number of dogs is 3. So when we run this program, it says you have a cat. But we initialize pet to 1. They have a dog. But our program's saying you have a cat. And so in this case, what's happening? We have our if statement, if pet equals 1. That's evaluating as true. Then we're doing our next if statement. If number of dogs is greater than 5, it would have said you have too many dogs, but number of dogs is 3. But that else statement is matching to that second if. So when number of dogs is not greater than 5, it's saying you have a cat. And so just because our indentation says that else statement should go with the statement if pet's equal to 1, C is actually associating the else with the first. Let's call it elseless if. And so how would we solve this problem? This is just a logic error. We've got the same program, if pet equals 1 and number of dogs equals 3. So now we're saying if pet is equal to 1, and we're using a compound statement. Within that compound statement, we're testing is number of dogs greater than 5. If it is, it would see the message you have many dogs. Otherwise, now because we've done the compound statement, that else is associated with that first if. So when we run this, we don't see any output. Why is that? Because the number of dogs wasn't greater than or equal to 5. Let's say they have 7 dogs. Run the program again. Sure enough, it says you have many dogs. And so our first if statement evaluated is true. Our second if statement evaluated is true. If we go back and change it and run the program, our first if statement will evaluate as true. Our second if statement will evaluate as false. So we don't see this message. And this else statement was associated with this first if, so it doesn't execute because this one was true. So you need to be careful when you nest if statements to make sure that your else statement is corresponding to the correct if statement that you desired. So far we've used the if-else statement to allow us to execute one set of statements when a condition is true, otherwise a different set of conditions. Using the if statement, we can test kind of in series for a variety of things. And so in this case, we've got our variable pet. we're assigning it to value 1. Our test says if pet equals 0, say something about cats. Otherwise, if pet equals 1, say something about dogs. Otherwise, if pet equals 2, say something about horses. 3, say something about birds. Otherwise, it says you should get a pet. And so we've got a series of else-if statements that allow us to test for multiple conditions. When we run this program, we see the message for dogs. Let's go ahead and change the variable that we're assigning and give the person a parrot. They've got a bird. We run it again. Our else statement says birds. And so by using a series of if-else statements, we can build a series of tests. And so C was going to find the one that matches and execute the correct code. And then if none of them match, we're going to execute the code for that final else statement. So if we say pets equal 9 and we run our program, sure enough, none of the if-else statements are evaluated as true. So we get down to this last else statement and it says you should get a pet. Now when we want to test for multiple possibilities, C provides the switch statement, which allows us to test for those possibilities by specifying a case. And so let's look at this one and then we'll kind of talk through how it works. In this case, we've got our program. It's declaring the variable letter and assigning it the value A. We're then taking a look at the value that's been assigned to the variable in our switch. And once our switch occurs, C tries to find a match. Is it A? Is it E? Is it I? Is it O? Is it U? And if it is, it's going to print this letter as a vowel. And so it allows us a quick way to test for multiple conditions in a format that this is pretty readable. But there's some challenges to the switch statement that we'll see next. In our previous program, we used the switch statement to determine whether or not a letter was a vowel. And so we learned that we can specify the letter that we want to test within following the switch keyword, and then switch will try to find a matching case. And so in this case, it's going to see is it A, is it E, is it I, is it O, is it U. The issue is that once the C compiler finds a matching case, in this case, the letter A is going to match, the compiler will consider all the other cases that follow matching as well. So let's run this and you'll see what I mean. So we run it and it says the letter A matches A. Well, it should. But then each one of the cases are now considered true as well. So it says the A matches E. Well, it doesn't. And A matches I. Well, it doesn't. But this is how our switch statement behaves. And so the way we stop this processing is to use the C break statement. And so let's take a look at our example. In this case, we're saying if the letter is A, print that it matches. If it's E, print that matches E. If it's I, print that matches I. But you can see after each print statement, we have a break statement. A break says, hey, we found a match. Skip everything else that's in the switch. And so if it matches the letter A, it will print that message and then break, and they'll continue the program's execution at the first statement that follows the switch. If it matches the letter E, it'll print that statement and then break, so the program's execution follows at the first statement that follows the switch. So let's go ahead and run this. And sure enough, it says the letter A matches A, and the break statement caused us to continue our execution at the first statement following the if. So that worked. So when you use the switch statement, there may be times that you want to look for any one of these matches, and if it is, do some code. But if you're looking for a specific match and you want to do something, you need to use the break statement when you're finally done to tell it to continue the program's processing after the first statement that follows the switch. And so that we've learned, the switch statement allows us to test for multiple cases. And when we do, we can use the break statement to kick us out of the switch statement after we've done our processing. The switch statement also supports a default statement. In this case, we're testing to see is a letter A, E, I, O, or U. And if it is, we're saying it's a vowel. So any one of those, we want to execute the same code. So our break statement doesn't occur until after our printf statement. But if it's not one of those, we want to have the default case that it's a constant. So let's go ahead and run this. It says A is equal to a val. Okay, that's correct, but let's change this to the letter B and run it again. In this case, none of our cases that we specified matched, so C executes the default, which is to say the letter is a consonant. And so as you use switch statements, you can use the default in a convenient fashion. And so in this case, we didn't provide a break after the default because it was the last statement in our switch anyways. So what are we going to learn next? Programs must often repeat a set of instructions, such as displaying a menu until the user selects quit, or looping through a set of values, reading all the information in a file. Such processing is called iterative processing. And to perform iterative processing, we use the C for statement, while statement, and do statement. Here's some examples of each. The first one is just reading data from a buffer, a file, until the end of file is found. And with each one, it displays the characters that it read. The next one is using a for loop, just to loop through numbers of a loop from I equals 0 to as long as I is less than 10, display the number and increment it. And the final one displays the world message, hello world, forever. And so it's kind of an infinite loop. In the next lesson, we're going to take a look at the C, while, for, and do while loops to perform iterative processing.